Morning, guys. I had some technical difficulties yesterday. This is the answer key to the free response question that I posted yesterday. Remember, I'm only posting one every other day, so I posted this yesterday, Monday, and today. If you didn't get a chance to do this question yet, go ahead and read it and work on it to best of your ability, and then come back to this video, watch it, and see how well you did. This question for part A asks you to construct and interpret a 95% confidence interval. And again, whenever it asks you to do that, that's when you want to do your 4 steps, which is state, plan, do, conclude. And in step 1, I know we've been used to doing hypothesis testing, which is like the ho and the ha, and saying we want to test the claim. We don't have to do that for a confidence interval. For a confidence interval, you're just trying to estimate what something is. And in this case, we're trying to estimate the proportion of this guy's customers that if they ask for a water cup, they're actually going to fill it up with soda. So this is a confidence interval for a proportion. So we want to estimate the true proportion of all customers that would fill a water cup up with soda. That's all you got to do for step 1. For step 2, this is where you got to do a couple things. You want to not only check your conditions to make sure that you can continue to do the problem, you also want to write down what your procedure is. So I did a whole graphic organizer of all the different tests, all the different parts of inference that we've done. I think that was the last lesson in our inference folder. Let me see. Yeah, if you go to the inference folder and go all the way down to the last lesson, number 28. This is all of the different kinds of inference tests that we've done. There's confidence intervals, and then there's hypothesis tests. So this is a confidence interval. It's for a proportion, and there's only one group of people, which I'll get back to in a second. So that makes this a 1 prop z interval. I'm looking right over here. So going back to the problem, I wrote down that it's a 1 prop z interval, and then you have to check 3 conditions. One of them is random, and it says in the problem that it is a random sample of 80 customers, so I put a check next to that. Independent, you want to make sure that this is an independent random sample. You want to make sure that these 80 customers, if he takes another sample of 80 customers on another day, that you're not going to get the same people. You want to make sure that it's a different independent group. And the way that occurs is if the population is large enough. So you do the 10% condition. You assume that the population is at least 10 times your sample size, so 10 times 80, which is 800 customers. We're going to have to assume that there's at least 800 customers that go into this guy's shop, and we can do that. And then normal. And normal, the way you check normal for proportions is not the same as the way you check normal for means. The way you check normal for proportions is you do n times p hat and n times 1 minus p hat. Those two products have to be larger than 10. The whole central limit theorem and the sample size being larger than 30 only applies to a means question. So n is 80, that's your sample size. P hat is 0.2875, and I got that by doing the work over here. Sometimes it gives it to you, sometimes it does not. Out of those 80 customers, it said that 23 of them actually fill up a water cup with soda, so 23 out of 80 is 0.2875. 80 times 0.2875 is larger than 10. So 80 times 1 minus that is also larger than 10. You can check it in a calculator, but it does work. So that's what you got to do for step 2. Step 3 is your formula. Now, you don't need to write down estimate plus or minus margin of error. I'm just kind of showing you guys my thought process. That's how you make a confidence interval. It's the estimate plus or minus the margin of error. The estimate is that p hat from earlier, which is 0.2875 plus or minus. The z star is 1.96. That's called the critical value. And that comes from table B. Go to tables and go down to table B. And you'll notice if you go all the way down to the bottom for a 95% confidence interval, the number right above it is 1.96. Now, all those other numbers above it, those are the T stars if this was a means question, but we're not doing that right now. So as long as you're looking for a Z star, and proportions is always Z, you're just going to look at that bottom row. So for this one, it's 1.96. And then your margin of error is also times the square root of p hat times 1 minus p hat over n. So I put the numbers in. And then you go to your calculator. All right, and the way that you do that in the calculator is you push stat, you go to the right to tests, and you go down to option A for one prophecy interval. I still am waiting to hear from a lot of you with regard to who needs a graphing calculator. I have a list right now of 10 students, but I know for a fact there's at least 10 to 15 more that do not own a graphing calculator. So please send me a message on Remind. I'd like to get that to Mr. Doherty by the end of the week so that we can start working on a plan to get you guys what you need. The confidence interval for the proportion of customers is between 0.18832 and 0.38668. This is the proportion, or the true proportion of all this guy's customers that would fill up a water cup with soda is somewhere in between those two proportions. So step 4 is the conclusion. We are 95% confident that the true proportion of all customers that would fill a water cup with soda is somewhere between 0.18832 and 0.38668. If you want to round that to a different decimal value, go right ahead. So that's part A. Part B is a pretty cool question. Part B said that it costs this manager 25 cents every time somebody asks for a water cup and then fills it up with soda. And in the month of June, there were 3,000 customers. So we got to figure out an interval of how much money this guy is going to cost him. So the interval from part A is an interval of the proportion of his customers. You know, if I just to round off to the hundreds place to make this easier to say, between like 19% and around 39% of his customers are going to do this thing where they ask him for a water cup and they fill it up with soda. So how can I turn that into an amount of people so that I can then figure out how much money it's going to cost him? So to turn these proportions, 0.18832 to 0.38668, into the amount of people, I just multiplied by 3,000 customers. All right, so what is the point, 19% of 3,000 customers to 38 or 39% of 3,000 customers? Multiply by 3,000, and that gives you, and I'm rounding, 565 to 1,160 customers. That's not money, that's customers. Let me fill that in here. The question doesn't want to know an interval of the customers that are going to do this. He wants to know the interval of how much it's going to cost him. So to figure out how much that's going to cost him, now I'm going to multiply each of those numbers by the 25 cents. Multiply by 0.25, and that gives you this interval here, which is the answer. It's going to cost him around somewhere between $141.25 to $290. Now, if your numbers are a little bit off there because you rounded differently, hey, that's fine. Doesn't matter. So that's how you do this question. I'm going to go into Google Meet and see if you guys need any extra help on this or any other problems. And since tomorrow is Wednesday, I will then post another new question. And don't forget, I'm going to be doing another afternoon review session this week. I'll do Google Meet on Thursday at 3 o'clock just to give you guys another opportunity to log on later in the day because I know some of you guys can't make the morning. But again, I still have my Google Meet every morning, 9 to 10:30. All right, I'll talk to you guys later.